Today we're looking at maximum and minimum problems, specifically perimeter and area problems. In these questions, there will not be given an equation, so you will have to develop the equation based off the information given, and the equation will involve the area formula and the perimeter formula. Read through the problem, understand the problem, and draw a sketch with the given dimensions. In example 1, a gardener has 30 concrete blocks, each 1 meter long, to enclose a rectangular garden. What should be the dimensions of the garden in order to maximize the area? What is the maximum area? Let's draw a diagram to illustrate the scenario. So we have a rectangle with a length and a width. The perimeter formula would be 2L plus W, or it can be written as 2L plus 2W, which would make that easier for solving. We know that the perimeter would be equal to 30, and we would also be working with integer dimensions since the blocks for the fencing would be 1 meter, and that cannot be split up. Okay, so we can write the perimeter equal to 30 in our equation. We also have area that needs to be maximized. The area formula for a rectangle being length times width. So the problem with solving is that we have two variables, but we have two equations, both with the same variable. So we can solve for either the length or the width in the perimeter formula and substitute that isolated variable into the area formula. So we will need to manipulate the perimeter formula a little to solve for, let's say we'll solve for the width. Okay, so we can write 2W is equal to 30, take away 2 times the length. So I've isolated 2W into that formula. Now we will isolate W by dividing both sides by 2. So we get that the width is equal to 15 minus the length. We can now substitute the width into our area formula. So we can write area is equal to the length times the width, which is 15 minus the length. Expand, you get 15 times the length minus the length squared. So we now have our area formula in standard form, not in factored form. So we can now complete the square for this formula for area, which is in terms of the length, to find the maximum. Okay, so factoring out the coefficient of -1, inside the bracket we want to create the perfect square trinomial. So we have to take 15 divided by 2 and square it. That would be 56.25. And go ahead and use decimals here for measurements. And of course we want to subtract that value as well. In our next step, we are moving the subtracted value outside of the bracket after we multiply it by the negative coefficient, which we factored out at the start. So it actually is positive, which makes sense because we know this is where we're going to get our maximum area from, and the maximum area would have to be a positive value. Let's move that up a little, and let's finish this off by writing the binomial squared here. We would have L take away, and that would be, remember, that comes from the square root of 56.25. Really was just 15 divided by 2 before we squared it. So that's 7.5, all squared, plus 56.25. So we can quickly find our width, which was 15 minus the length, so 15 take away 7.5. Oh, the width is the same. Okay, so we've got a length and a width that are the same. That means we have a square. Maybe remember from grade 9, we talked about maximum area. For maximizing the area of a rectangle, a closed rectangle would always be a square. Okay, so therefore, we can conclude that the maximum area is 56.25 meters squared. And the dimensions that would give that, okay, that would be from a 7.5 by 7.5 meter square. For example 2, a rectangular lot is bordered on one side by a stream and on the other sides by 600 meters of fencing. Find the dimensions of the lot if its area is a maximum. Okay, so a rectangular lot has 3 sides. One side is a stream. Okay, so we would have a width and another width, and then we would have a length here. And we've been told that the perimeter is 600 meters. But we can't use the usual perimeter formula because we don't have 2 lengths. We have a length and we have 2 widths. Okay, so 600 meters is equal to length plus 2 widths. And the other formula that we're going to need would be area. Area is still area. It would be length times width. Okay, so we're going to have to solve for a variable in our perimeter formula. It would be very easy for us to solve for the length since there's no coefficient there. So there's our length, and we're going to replace that into the area formula. Area is equal to length, so 600 minus 2w multiplied by the width, length times width. Okay, we want to write this in expanded form. Okay, so we have negative 2w multiplied by w, negative 2w squared, and w multiplied with positive 600, so positive 600w. We're going to complete the square to find our maximum. So we're going to factor out that negative 2. Create the perfect square trinomial. So we want to take the 300 divided by 2, we get 150. We want to square that. Add and subtract that value inside the bracket. Move the value that was subtracted outside of the bracket. After we multiply it by negative 2, of course. Okay, so we would have plus, and now writing the final equation. Okay, so we want to figure out the other dimension. We know that the width would be equal to 150, which we can see here. So finding the length, remember the length is equal to 600 minus 2 times w, which is 150, so we're subtracting 300 from 600, so our length would be equal to 300. Okay, so the question was just asking us to find the dimensions. We know the maximum area. If the question was asking for the maximum area, we could report this value, but the question's only asking for the dimensions, so our therefore sentence should just reflect what was being asked for. Okay, the dimensions are 150 meters by 300 meters. Example 3. A rectangular pasture is enclosed by a fence and divided by another fence parallel to the two shorter sides as shown. If the 600 meters of fencing encloses a maximum area, what are the dimensions of the enclosure? Okay, so let's label. We have 3 widths and we have 2 lengths. Okay, so that's all of our fencing, which must add up to 600 meters. So our perimeter formula would be 2L plus 3W. So 600 is equal to 2 lengths plus 3 widths. And we also have our area formula. Okay, the area formula that we want to use here is just still length times width. We are looking at the area, so there's no change to that formula. So we're going to isolate either the length or the width in this formula for the perimeter. We'll go ahead and isolate the length, so we'll isolate 2 lengths by subtracting 3 widths from the perimeter. Okay, and then divide everything by 2. Okay, so we have 300 minus 3/2 the width is equal to the length. Right? We can go ahead and actually write that as 1.5. We're dealing with measurements here, so that will make it actually easier. Okay, so let's go ahead and substitute this into our area formula here. The length is 300 minus 1.5 times the width. Put some brackets around that, and length times width. Okay, we're going to expand that. So we'll have negative 1.5 times the width squared plus 300 times the width. Okay, now in order to maximize our area, we're going to begin completing the square. We'll factor out the W squared coefficient. We are dividing 300 by negative 1.5. Create the perfect square trinomial inside the bracket. Okay, so divide 200 by 2, and that would be 100, which we want to square. And subtract that value as well. I'm going to move the subtracted value outside of the bracket now by multiplying it with negative 1.5. Okay, and then writing our final equation in vertex form. Okay, so we have our vertex, so therefore we know our maximum area. Okay, that's what the question's asking for. And it's also asking the dimensions of the enclosure. So let's determine the other dimension now. Okay, so remember that the length was equal to 300 minus 1.5 times our width, which is 100. Okay, so we do that work, we get 150 for our length. Okay, and now we'll conclude. Okay, so therefore, the dimensions are 150 meters by 100 meters the maximum area is 15,000 meters squared. Okay, so enough about rectangles. Determine the maximum area of a triangle in square centimeters if the sum of its base and its height is equal to 13. Okay, so we have the height here, we have the base here. Okay, and we can write out, as it's indicated in the question, that adding the base and the height is equal to 13. And we also know the area formula. The area formula, 1/2 base times height, so let's just write 0.5, half the base, times the height like that. Okay, we can either isolate the base or the height in this first equation here, so let's just go ahead and write that the base would be equal to 13 minus the height. We're going to replace the base with this in our area formula. So 0.5 times the base times the height. So we have an equation with just height, and now we're going to expand. So we'll leave the 0.5 for now and just multiply through by the height. And so I'll get negative h squared plus 13h. Okay, so let's go ahead and multiply by 0.5. So we have negative 0.5 h squared minus 6.5 h. Right, so in the next line, yes, we're going to factor out negative 0.5. So if you thought about it, we could have just factored out the negative in 2 lines above. Okay, so we get negative 0.5 h squared minus 13h. Build the perfect square trinomial. H squared minus 13h, divide 13 by 2 and square it. So we get 42.25. We're going to add and subtract that number. Okay, negative 0.5. Move the subtracted value out, which we would have to multiply by negative 0.5. Okay, so we do that, 42.25 multiplied by 0.5, this is going to be positive, and we get 21.125. Don't round anything, we don't need to round. We can round the final answer if we like, but don't round in between. Okay, so our equation, negative 0.5 h minus, we take the square root of 42.25, or remember that would just be half of the 13 in the first place. So 6.5 all squared plus 21.125. Okay, so question was find the maximum area. That's all we needed. So we're done. All we have to do is conclude about our maximum area here. So therefore, the maximum area is 21.125 centimeters squared. Okay, so we'll get plenty of practice with these area problems tomorrow, and you can look for full solutions posted in your lesson files to recap this concept. And feel free to watch this video again if you need to hear more details.